Well, wherever you are in the world, welcome to this webinar from Monotch. So good morning, good afternoon, or good evening. For the next hour, we're going to talk about from pilot to proven impact, connected mobility and digital infrastructure with the help of our guest, Steve Voit, who's Business Development Americas for Monotch and the company's CEO, Menno, Malta. Now, so many different parts of our industry will benefit from today's webinar. Infrastructure owner-operators will learn how to future-proof their early investment and how to position for smart grant funding. System integrators will learn lessons from a connected mobility deployment at scale and what architecture and government models work. And roadside equipment makers will learn how interoperability can add value and accelerate use of their technology. Now, this is very much a two-way process, and we want to hear from you too. So please do put your questions into the Q&A box. It's at the top of your screen, and we'll come to as many questions as we can for you later on in the hour. But without further ado, let's cross to Steve Voit, who we can welcome now to discuss some of the challenges faced by the industry. Hello, Steve. The floor is yours, sir.
Thank you so much, Paul. And I'd like to extend a welcome to everyone here in all the various time zones that we've got. Let's begin by setting the stage. This will be a memorable presentation because of what we're going to cover. And this conversation, and in fact, this webinar is set in the context of unprecedented change and unprecedented budget support for connected services. And yet, the ambitions that are supported are not new. We have to ask ourselves, why were these past efforts, for all the activity that has gone into them, all the smart people, advanced technology, company and agency engagement, why is this yet to create an impact in the industry? And so I'd like to provide some context by making some observations. The first observation is that discussions tend to begin and end with a discussion of architecture. And in the light of day, this has to be misplaced energy. Certainly focusing on outcomes would be a better guide to a compelling endpoint. Another observation we can make is that, generally speaking, operational departments tend to fix challenges with solutions that suit their department. And this results in islands of automation, silos, if you will, with really no energy spent on sharing information and no appreciation for the fact that the maintenance of these overlapping systems becomes burdensome. And finally, another area that we observe that may contribute to a lack of impact is that there's no consumer audience. It's a bit like building Netflix without having the internet. In part, I think we can point to a focus on hardware-based direct connection only approaches. There's, I think, a situation where the developments over the last decade in cloud computing and 4G, 5G networks have not been built into some plans. And there's great opportunity as a result of that. But taken together, these observations explain why we are currently stuck in a cycle of pilots with repeated demonstrations and no scale up. And so the takeaway here is that the real challenge in front of us all is scaling. It's not piloting. And that frustration we can direct into turning our attention to how it is we can help. So first, let's look at the fact that any solution would involve multiple stakeholders. And here in this illustration, you see physical infrastructure owned by public and private organizations. On the left, we have the owners themselves, people and departments that are engaged in operational support and traffic operations, people that are doing research and analysis, coming up with annual plans, for example, or educational institutions. And finally, on the right, we've got the road users themselves. And these can be consumers, like regular individuals, or this could be road users in the form of emergency or agency-owned vehicles. But there's an observation that many great things can happen if we share data, not just downstream in a point solution, but among and between the various stakeholders. Another observation is that there's many use cases that are valuable, not just a golden one. And I think that this is proven to us and is generally accepted that from the pilots and demonstrations that have preceded, that there's value and improved safety and mobility and efficiency through these use cases. It's important to say that there's also some hurdles that we can observe when we look across the ecosystem. Some hurdles are of a technical origin. For example, it's concern for security, concern for data quality. Are the systems and is the data behind the systems that we're rolling out of a consistent quality to provide consistently valuable information? And is it done with enough speed that the use cases that we're endeavoring are going to be consistently reliable as well? And from an organizational standpoint, there are obstacles presented to us in terms of agreeing on standards, or agreeing on levels of privacy, or agreeing how it is that jurisdictions that are neighboring one another can participate and cooperate in a system. And so when you take the problem that we've observed in having a lack of impact, and you look at the opportunity to involve stakeholders of all sorts, you see that the challenges require a platform that can handle real-time data in a multi-stakeholder ecosystem. And that's precisely what we've done at Monotch with Traffic Live Exchange, TLEX. So I'd like to hand the presentation back, Paul, and we'll take it to the next chapter.
Thank you very much, Steve. Let's go on now to a case study with Menno Malta, who'll run through talking traffic with us. Menno, over to you.
Thank you, Paul. Well, it's always a pleasure to talk about real-world deployments. And in this case, I will share a bit about our work in the Netherlands, where we have a great example of a nationwide deployment of digital infrastructure and connected mobility. And for those of you who don't know the Netherlands that well, it's the 18th largest economy in the world, and the population is comparable to the greater Los Angeles area, so around 18 million people. So with that, over to Talking Traffic. And Talking Traffic is a deployment program that started in 2017. So obviously, a lot of work has been done since 2017. And I cannot share all of that in this webinar today. My goal is not so much to go into all the details, but really to give all of you a feel about how an ecosystem such as Steve described looks like in the real world. And those of you who are interested in the details such as security, interoperability, etc., interfacing, please let us know. We're always happy to answer any additional questions. So with that said, let's have a look at what Talking Traffic really is and what it is about. And it's all about realizing a cooperation between roadside infrastructure and road users. Over 60 agencies in the country of the Netherlands participate in this deployment, and these include municipalities, regional authorities, and also highway authorities. And besides the authorities, there's also a large group of service providers that participate. And these are apps, onboard units, but also specific fleets and the navigation companies such as TomTom. But today we also see car OEMs directly join the ecosystem and contribute and take this data out of the ecosystem. And the initial phase was co-funded by the Ministry of Infrastructure and Waterworks, so you can compare to sort of the Ministry of Transport that we see in other countries. So now fast forward to today, where all these efforts have brought us. And we started with connecting traffic lights and making them smart. And we have today over 25% of all the traffic lights in the country connected. And these traffic lights are from different vendors, they're from different cities, but they all have the same capabilities. We also have over 25% of all the motorized vehicles connected into this ecosystem. And when we say connected, it means that they share their position, their direction, their speed, and the vehicle type with the ecosystem. And we have all the ambulances in the Netherlands connected who share their status when they are on an emergency route and also use this environment to request priority. So it's a lot of connectivity. Now, to make this come alive a bit, and let me say that again, this is all bidirectional. So all the connected objects and all the connected vehicles both share data as well as that they consume data. We do this on the cellular network. I should not forget to say that. And we see an end-to-end latency of around 150 milliseconds, which is basically as fast as a human can see. In total, around 1.3 billion messages are exchanged in this ecosystem every day. Now, to make it come alive a bit more, I've here gathered some graphs from one of a traffic light controller in the Netherlands. And let me explain what you see right here. So here on the top right side, we have a graph saying spatberichten, which means messages. These are signal phase and timing messages. And every message tells us the status of every lane on the intersection, whether it's green, orange, or red, and also the planning for that particular lane. And what you see here, that a traffic light in the Netherlands, so all these connected traffic lights, basically share around between 8 to 10,000 messages per hour with the ecosystem. And in the top left graph, you see how that translates into the amount of messages per second. So it's between 2 and 3 messages per second that this traffic light controller sends out. Now, if you look at the smaller graph on the right saying CAM-berichten, CAM messages, this means cooperative awareness messages, and it's sort of the same type of messages as BSM messages in the US. And you see here that this intersection in the morning, so at peak hour, receives over 50,000 messages from the traffic in its surrounding. So you can see that there's quite a lot of data going back and forth, and there's a really complete coverage. And here on the bottom left, we see SRM messages. These are priority requests. So emergency vehicles request priority ahead of their approach. So they can, for instance, request priority for a certain lane 3 minutes ahead. And during their route, they will continue to update and their estimated time of arrival, so that the lanes are already cleared when the emergency vehicle arrives. And here you see on the left side, you see a bit of messages. Now, one step further of making this visible, and for that, I will actually show you a live dashboard of a particular traffic light. So I will switch to a browser right now. Oops, wait, that's not the right one. Here we have it. So what we see here is a larger intersection, which is a group of traffic lights on a roundabout. And what you see right now is the current status of these intersections. And it's already in the evening here, so traffic has diminished a bit. But you see all the dots, these are vehicles going over the intersection. And if I zoom in a bit, we also see the colors of the traffic lights. So we see here these lights are red, and here we see green traffic lights, and you also see the direction of the lanes. So and you really see the live situation, and we can do this for every intersection in the Netherlands. And here I've opened a few to give you an idea of this is more classic intersection. just to give you an idea about how real-time this platform is. So let me switch back to the presentation. There we are. So we have all this connectivity. What do we do with it? Today we have 4 use cases live at a nationwide scale. And first one is informing the road users. So the cars in the Netherlands know the status and the planning of the traffic lights, so they can adapt their speed when they approach an intersection. Then we also take all that data from these road users and we bring it in real time to the traffic light controller. And that allows the planning algorithm of the traffic light controller to really have a very real-time dynamic planning and improve the traffic flow. Now, we also use it to prioritize traffic. And this is not just emergency services. By bringing this functionality partly in the cloud, road authorities can configure priority policies in a very fine-grained way. And they can, for instance, prioritize logistical services in the morning, public transport only when it's behind schedule. And we even see cities in the Netherlands prioritizing bike platoons at certain times of the day. And in those situations, the bikes are detected with sensors such as radars or smart cameras. And then we use it to shorten the round trip of emergency vehicles by giving them priority, but also by informing all the traffic on the road in real time about an approaching emergency vehicle. With this ecosystem in place, it's actually quite easy to add more use cases. And this is exactly what is now happening in the Netherlands. So these 4 are live on a national scale, but in the meantime, we're adding other use cases. And I have a few here on the list. For instance, urban vehicle access regulations, environmental zones, what kind of vehicles are allowed access in these zones. But also private sites now connect to this ecosystem to make sure that emergency vehicles always have access to these locations. And you can think of larger plants with automated gates, but also campsites. So we see all these locations being connected to the ecosystem and the platform. And we also see more and more sensors being connected, allowing us to share information about hazardous locations in real time with all these connected vehicles. Besides these new use cases, we continue to see growing connections with other traffic lights, but also with other types of emergency vehicles and logistical fleets, and in general, more service providers and OEMs. So the benefits, and I think one of the reasons why this ecosystem has been so successful and being able to get to large scale is that there are benefits for all the stakeholders in the ecosystem. And so it's of course important for agencies because they are unburdened but still control their own territory, and it's important for road users because of the benefits that they get from the improved traffic flow and from less accidents. But there are also benefits for the industry here, allowing them to build new and profitable services. So that's roadside equipment suppliers, car OEMs, and traffic management solution providers. So all in all, lots of benefits here for the ecosystem. And I want to wrap up by sort of idea to give you a feel about the ecosystem with actually a story about impact. And quite recently, I had the opportunity to meet a group of ambulance drivers and listen to their stories. And that wasn't also so pretty. I think these pictures that you see here speak for themselves, even if you don't see the fatalities and the injured people. But quite clear that they have many dangerous situations when they are on immersion trip. But this is how crossing an intersection looks today for a Dutch ambulance driver. A clean intersection with lanes that already have been cleared out and a safe passage of the intersection. And this is really a tremendous improvement in safety for the drivers that directly translate to less accidents and faster travel times for emergency vehicles. So today in the Netherlands, 100% of the ambulances connected. Hopefully next year, 100% of all fire trucks. And with that, we're saving lives every day. So with that, I hand it over to you again, Paul.
Fascinating stuff there. Thank you very much indeed for that, Menno. Now, I have been scribbling a large number of notes down as both Steve and Menno have been talking. Remember, there must be questions. There must be things you want to know based on what you've heard already and what you're going to hear from Steve in a moment. The place to go is the Q&A section on your Teams screen. Go in there, ask your question. We will come to the questions in about 20 minutes time. But for now, let's return to Steve to find out, what does all this mean for you and what can Monotch do to help? Steve, tell us some details of the TLEX software platform.
Thank you, Paul, for that introduction. And also, Menno, thanks for covering an important install in the Netherlands. I think I just want to amplify that not only is that a nationwide system with growing use cases being added, but in that geography alone, there's over 1.5 billion ITS messages exchanged each and every day. So it's something that's operating at scale. And that is a great lead-in to a discussion of the platform itself. And I want to explain to you at a rather high level the platform and its capability. And I want to call attention to the way that the technology itself is responsible for increasing cooperation between the stakeholders. If that's a takeaway that's important in this conversation. So let's first look at why an interoperability platform is necessary in the first place. If you look at the illustration on the left, you'll see a single service. And so this is an agency who has authorized data to go to a service provider. The service provider generally is a back office system. It's a vendor, it's software. And it takes data from the agency and may augment it with other information and route that to the driver's environment, which could be a private citizen or an agency employee. In this case, we're talking about an approaching emergency vehicle. So this is the information on the direction, speed, and location of an ambulance. Going to a service provider who knows where vehicles are in the vicinity, a la the demonstration that you saw, the live demonstration that Menno put up on the screen. And together that information can create alerts into vehicles saying ambulance approaching from behind or whatever. Okay, so that is a classic arrangement of a point solution. And when that is increased, either with more agencies, adding roadworks or the DOT, or maybe other jurisdictions where you're adding adjacent cities with one another and connecting them in the middle illustration with more services, you see very quickly that adding capability to the broader system gets very complicated in a hurry. In fact, it approaches a mesh type network in a hurry. And this results in a lot of burden when you look at the number of integrations, controlling data policies, controlling security, controlling privileges between many different players. On the right, you can see how a data exchange at the center simplifies the arrangement. The key function here is that every stakeholder can publish and consume information. And if you need to add a stakeholder, maybe a new service, maybe a new group of vehicle users, maybe a new jurisdiction, it's a matter of connecting once and configuring permissions to share information with the appropriate parties. So there's 3 takeaways here to this kind of an architecture, and that is reducing complexity and expense for maintaining all these integrations, taking the burden away from the infrastructure owner-operator, encouraging data sharing between different applications. So that ambulance alert that helps speed ambulances might also know of vulnerable road users in the neighborhood, for example, but then also encouraging new use cases. With that, I'll transition to a different view of the same system. So here the data exchange is now labeled with Traffic Live Exchange, TLEX, the name of our product. And this is interfaced with infrastructure, sensors, and third-party data systems. So you might have vendors that are supplying speed or volume information or parking availability. The platform's in the middle. Any stakeholder type is supported. And I want to call attention to what we've been calling service providers. These, with every use case, more than likely is a service, which is typically an organization, a company, software, which takes the data that it's allowed to have from the broader system, comes up with a informational message for the vehicle, and then transmits that via the public wireless network into the vehicle. So unlike a point solution, there's no winners and losers. By that I mean that all stakeholders can participate, and each jurisdiction can use their own choice of technology because it in essence is all possible. So there are 5 functional areas that are supported for all users. At the top is a high volume, high bit rate, ultra low latency, multi-protocol data exchange. There's real-time data quality monitoring and control for accurate insights. Extensive governance support, which gives infrastructure owners control of their use case, especially when you're in the situation with multi-jurisdictional participants. There's analytics and alert features for dashboarding and reporting. And finally, there's security features, as you would expect, security features that meet strict, widely accepted specification. And all of these things are optimized for connected mobility at scale. All the technology is encouraging stakeholder cooperation. So while it's very broad in its capability, it's also very much focused on the low latency, super high availability, high throughput approach that traffic at scale requires. Now, I'd like to elaborate on 3 different functional areas, 3 that I've mentioned just previously, but give you maybe a little bit more insight into what's possible. The first example is a governance example where transit prioritization is being applied to 12 miles of bus route that crosses 28 key intersections and 5 different jurisdictions. And this is from a stage 1 SMART grant proposal. The SMART grant says that within the 18-month cycle, not only will technology be put in place to pilot this in a couple intersections, but all of the regional participants are going to agree on the regional system. They're going to agree on the technology and the policies and the operation of the system. But how easy is that actually to do? When I've been in presentations surrounding getting people to agree on transit prioritization, as I was at a recent ITS meeting, the consultants associated agreed that this takes a lot of time. And even the vendors said that there is going to be winners and losers. So is it realistic to think that people will come together in a short amount of time? And why should they have to? TLEX lets the cities retain control. So if in the case of say Fullerton and Anaheim, they can be running different signals, different vendors, different signal operation approaches. They may have different local improvements operating on different network types. They might disagree on what service provider would be their choice for prioritization and what policies would be followed. And certainly they each have their own transportation plans and priorities. The point here is that because of the interoperability and the policy and governance control, we're encouraging jurisdictional cooperation because each of these communities can participate in a regional solution, but in a sense, have it their own way. The next area that I'd like to talk about is that of quality control. Quality is critical when you think of utilizing data at scale. For example, if you had 100 different traffic light controllers, which is a fraction of what Menno was talking about earlier, and one of these controllers were to have its clock lose synchronization, you suddenly have a flood of information that is anomalous. And the question is, how do you deal with that? And how do you pick it up on it in real time? So data at scale needs automated monitoring and automated intervention. And we look after that 3 different ways. We look at the connections, the quality of the connection, the uptime and the latency, and monitor that. We look at messages inside the payload for format compliance, such that when an intersection provides map information to an application, or when a vehicle is returning its basic safety message, we check that that is within the format compliance and is meeting the specification of the system and useful to all players. And finally, we look at use case quality. Because we have, with permissions granted appropriately, we have view of the messages, requests, the results, the traffic light status, we're able to judge the efficacy of the use case. If it's transit prioritization, did the vehicle arrive with a green light? If not, what was the delay? Overall, what is the preponderance of performance, and how might that compare from region A to region B or vendor A to vendor B? So with the data being identified, then we take a response, and the response can be to alert the authority, to flag a source as being suspicious, possibly immediately dropping messages or blocking the data stream in its entirety. And this is because with every member able to publish or consume information, provided privileges, data quality is a responsibility of each stakeholder in the system, and we enable this cooperation. Okay, and finally, I'd like to talk about how TLEX provides interagency federation. This is the 3rd example I want to cover of cooperative technology. So the infrastructure owner can establish its data exchange knowing that TLEX will take care of federation. And federation is a little bit like the miracle of roaming. Recall getting off an aircraft in a different country and launching your phone and having it understand where it's at, understand what resources are available to it, establish permissions that are native to you, such that you can carry on your life as you would in another location, just as if you were in your home location. That's pretty fantastic, and that's what we're talking about here with federation. So in this picture, this is in Southern California. A couple small boxes. One is to depict, for example, Los Angeles, and the other might depict Orange County. And if those 2 systems were to be federated, then you could have a larger box, logical box, that is, and that might be the LA metro area, which itself might be federated with a broader initiative in the state of California, such that California would include the metro areas. And this makes a great deal of sense. We see that our federal authorities, the Federal Highway Administration, for example, is advocating publicly a multi-state corridor to display some of these technologies. And in this example, you would federate whatever exists in California with the system as it exists in Arizona, New Mexico, Texas. You get the idea. This is I-10 corridor. So we will guarantee that TLEX, our product delivered today, will comply with future government standards. We're so confident in the approach and the way that our product is put together. Okay, there's been mention of smart grants, and I think it's really important to look specifically at how we help with smart grants, or grants of any sort for that matter. In the first cohort of smart grant applications, only 1 out of 6 applicants were selected for funding. And you can come up with different reasons why. I think the fact does remain that there are a lot of requirements. There are a lot of requirements that are difficult to meet unless you properly architect or anticipate them. And adding TLEX to your proposed system meets these requirements head on. I'd like to look at some examples of that. The FHWA, for example, is looking for results and data to support not only the efficacy of a solution, but to support the benefit at scale. And by using TLEX, you've got access to performance metrics against measurable targets, use case performance, as I mentioned. We can document comparisons between baseline, between different vendors, between different approaches. This is inherent in having a centralized data system. Additionally, the grants are requiring speedy work. The grant itself is 18 months, and that includes get funding, get your team together, get the plan together, agree on roles, agree on policies, create a deployment, create results, document all this. With TLEX in the mix, we can help with all of that speed. For starters, the system itself installs very quickly because it is, after all, a production system, and it deploys on public or private cloud resources. So getting the system up and running is a matter of days, weeks, not months. And one of the key requirements in smart grants is that within 90 days, there's a data evaluation and data management plan put together. We certainly support that with the functionality in the product. And we can also, as I mentioned before, help jurisdictions agree on a go-forward plan, because the jurisdictions are able to configure technology and select vendors and deploy things in a manner that's in keeping with their own priorities, even though they're participating in a broader solution. And the data management requirements are very specific and non-negotiable in the smart grant process, and certainly in other grants as well. We address data collection, storage, security, privacy, access control, and reporting. So this is a broad set of functionality that is taken care of by using TLEX. And finally, if a vision is required for the future, by solving multi-jurisdiction issues, by using capability that is clearly demonstrated, by having guaranteed support toward the future, we put you in a position to benefit greatly from using TLEX, and it scales from small to large. So you can involve TLEX in a pilot or demonstration installation. It's a very small lift to do, and yet that same effort will scale into a production system with huge amounts of stakeholders and data being exchanged. I'd like to say that we're ready to help all of you on this call today, and we can proceed with what you have going today and build toward the future in mind. So certainly agencies are interested in improving mobility. Many of you are contemplating or involved currently with smart grant funding. We're in a position to share our lessons learned and to work with your team and ultimately maximize the outcomes in your area. If you're an integrator, certainly you're concerned with delivering best-of-breed solutions. We're in a position to help you reduce risk on behalf of your client and give your proposal quick and precise responses and leveraging our experience at scale. So we're in a position to help support your business as a trusted best-in-class supplier. And if you're a roadside equipment manufacturer, your interest is to work and integrate alongside other kinds of technologies. And we're in a position to support multiple use cases and to share your data with others, given permissions, of course, and thereby increasing the value of your solution and leveraging your integration across more than one use. And so it leaves us with a conclusion. And that is that this is a standards-based connected mobility and digital infrastructure platform. As you saw in Menno's demonstration, it operates at scale and provides interoperability for all stakeholders. It's not a generic platform. It's not an IoT platform. It's not a generic message broker. It's not a point solution that has been augmented to have certain other data types brought in. If it were a car, TLEX would be a race car, and it's a race car that has a perfect record. We guarantee every aspect of our business, from service level agreements to ongoing compliance with evolving standards, to security, to satisfaction. And so our message to you here is please bring us into the conversation and see how we can help, because we're in a position to help and we'd love to talk to you. I have on the screen here right now QR codes for information. We'll put this up after the Q&A so that you'll have a chance to get at this. Just know that there will be ways for you to get more information, and I'd encourage you to contact any of us with addresses on the screen that will be up on the screen later on. And with that, I'm going to close the presentation itself and hand things back over to our trusty host, Paul Hutton.
Thank you very much indeed. Can I first of all just say that 20 years ago, I worked on a data exchange project for the Highways Agency here in England. And if only then I could have used your explanation for the need of a data exchange. That was the best explanation I've
Hey,
ever
I love
seen
that. Thank
for the
you.
need of a data exchange. Now, I will point out that also it is pouring with rain in England here at the moment. So you showing maps of Southern California has just made me glum and yearn for the sunshine and the warmth of Southern California in December, but I won't hold that against you, Steve. Fascinating stuff. Now, we've had a question come into the chat. I'd like to ask you, if you're watching this webinar and you want to ask a question, ideally please use the Q&A, just because then everything's in one place and I don't have to go clicking between them on here. But I will ask this question that's come in, which asks, can you say a bit more about cooperative messages that Menno, you mentioned? Because, and just a reminder, Menno, you're on mute at the moment, that the person, Kelly, who put the question into the chat, doesn't recognize the term that you used. So please, could you explain it?
Sure. I mentioned BSM messages, basic safety messages, and you could know them of their usage in DSRC, previous DSRC implementations in US. But really summarized, it is what I mentioned. It's sort of the vehicle type, status, position, speed, direction, and there are some additional fields. And these are typically encoded messages to really make them small so we can keep the latency low. And in Europe, it's the same message, but we just have a different name for it. Here we call it cooperative awareness message.
Okay.
And I hope that answers the question.
I think that did. Any more questions, don't forget, go into the Q&A. I've got a few I've been tapping away on. I've been scribbling and typing on my second screen. So the questions that I just want to know is, what if organizations don't have CITS capable infrastructure? How could you implement such a project?
Steve, you want to take a answer this one, or
Go ahead. Yeah.
well, I think this is actually the question is where to start. So if the ambition is there to become active in, and whether you call this CITS or digitalization in general or connected mobility, I think it's sort of all the same. But this is actually a great place to start, because this is a platform you can use for a pilot and scale it up during your journey. So you can also use it for smaller, let's say, pilots, proof of concepts, demonstrations, etc. And I think authorities be surprised how much is possible already with in a very affordable way. So with the relationships that we have with most of the suppliers of roadside equipment in the market, also in the US, and also other stakeholders, the service providers that I mentioned, and we also are in touch with the players in the US. So much more is possible than agencies might think.
Okay, fair enough. Now, here's my phone. I update my phone probably once every 2 years. Technology is moving on. You have procurement timings that could be 5-10 years, where technology is so much quicker. How do we know that going with you is going to be future proofed?
Well, I think you can look at that from a few different angles. I did mention the future proof regarding federation, and that's to assure anyone that uses our platform that we're going to stay current with standards and evolve our product as might be necessary to stay current with the standards. And I think that we benefit by using the public network because they are, in fact, doing their own future proofing. I'm aware of one carrier here in the US alone that spent $50 billion in the last 12 months on buying and upgrading their network. But at the core of what we do is the message of interoperability. So regardless of network connection type, regardless of data type, by putting a message exchange platform in the center, you're assuring that all parties will be able to communicate with one another in the future. And I think that's an important takeaway here. That is the essence of future proofing. I don't know if Menno, you'd like to add anything on top of that?
Well, maybe something about the platform itself. So this is a product. This is a product that is maintained and developed continuously. So we release 2 times per year, basically, our upgraded and improved version of our product. And we also, that's already sort of a guarantee that there will be, it will be future proof. And we also guarantee actually that the platform stays compliant with all the relevant standards. So whenever standards are updated, we also take care of that in our basically bi-yearly updates.
I guess that actually we've got to remember here, or I've got to remember when I'm chatting to you guys, that this isn't some great new idea that you're launching and throwing together. This is a here and now product that is working in the Netherlands, is making a difference in the Netherlands, and you're constantly facing the issue of more and more data sources coming online.
Yes, and of course we did use the Netherlands as a showcase here, but it's not the only country where this platform is running. This is live in 6 European countries. So and the Netherlands is sort of our flagship deployment since we started here. So we started our journey a bit longer ago here, and therefore we have more connectivity. But we take all of these partnerships, these connections, this functionality, and we use it in our other deployments also.
Yeah. No, I'd just like to add something to that. When you look at the programs that the U.S. government is sponsoring, Smart Grant is a great example. The program is designed to encourage the use of technology that exists today to improve safety and efficiency and equity and transportation. And the key takeaway from the Netherlands, as far as that's concerned, is that there's a virtuous network that has been established, that by connecting things and having the day one use cases, that's a fabulous technology accomplishment. But then to have other use cases in the time since 2017 through 2023, to have an additional 5 or 6 use cases added is great. And then to have service providers approach the system and want to connect up with that system so that they can get information to vehicles, and to have auto OEMs knock on the door and express interest in being connected as a way to bring services into the vehicles. That's exactly what the U.S. government is hoping to achieve. And so people have kind of jokingly told me that I'm a little bit too passionate about this, but I recognize that things have to be done in the U.S. per local priorities and so on. I just feel like the lessons learned in the Netherlands can go a long way toward accelerating these use cases here in the States.
Excellent. Now, I want to ask a question I remember came up 3 separate times in a webinar that we did earlier in the year. And I know the answer to it, but I just want to hear it from one of your mouths, which the question was something along the lines of, we've already got infrastructure partners. do we have to replace what we've got with something else if we go with your platform? So do you just want to allay any fears on that again, please?
Menno?
Obviously not, because that wouldn't work at all. So we bridge interfacing with our platform, and so actually we have sat down with the industry companies such as Unix and Swarco, or amongst them, and we have with that group developed an let's say CITS interface for roadside equipment, which is an open standard that is governed by public authorities. So we don't control it or something. It's really an open interface. Now this is now more and more used in the different European countries, but every country there's also legacy or existing deployments that are around, and we use the standards of that region or of that country to connect to the roadside equipment. Now it depends a bit on that particular interface, how low latency, that the possibilities that it gives to us. But for sure, the connectivity and the say the first level of use cases are doable with existing equipment.
Okay, fair enough. Yeah, I was actually in Swarco's headquarters just outside Innsbruck on Monday, and the talk about the importance of interoperability came up in the conversation I had there. So it's not just you saying that, it is very much right across the industry that the days of an organization showing up in a jurisdiction and trying to sell them everything and keep everybody else out just does not work anymore. What about people that have used other forms of communication like ITSG5 or WLAN-P or other sort of short distance communications that aren't using IP? Can they use the platform as well? Go on, who's going to take that one?
I think we both can answer that one. Okay, let me take care of that. Yes. So, and we have done that actually in the past, still doing that today in situations where there's a hybrid setup, and if short range, if you have short range capabilities, then that's good, that's great, and of course you need to have vehicles that also have that equipment, and that's not going to be all the vehicles, especially not today. So by adding the connectivity with this platform, you can also bring the information to road users that have no short-range capabilities. And on top of that, we've seen our platform being used just to gather a lot of intelligence about short-range deployments. So data quality, for instance, data message volumes, etc., etc.
Okay.
Yeah, I think along those lines, it's interesting to point out to our U.S. folks that there is a roughly 25% penetration with road users in the Netherlands, and this is predominantly on smartphones. And so while we're in the process of having direct communication and so on appear on the broader fleet, there's two things we can agree on, and that is that smartphones can save lives and deliver information today, and that when direct communication is more available, it's probably going to be a hybrid world where, as Menno just said, both things will happen at once.
The key thing here is that every car is connected if it has a smartphone in it.
Exactly.
As a journalist, I covered the London to Brighton veteran car run using vehicles that were built in 1899 to 1904. And one of the consultants, a guy called Andy Graham, actually connected up a 120-year-old vehicle and made it the world's oldest connected vehicle. And it had all the modern connection technology in a vehicle that was built, as I say, 120 years ago. I just want to ask about something where I was actually talking to a developer who's based in Amsterdam, but has been doing some work with some UK traffic data from the different national traffic authorities, all that use DATEX 2, a European standard. But he said it took him over a year to actually standardize their standard to make it one single pool of information. So how easy is it for service providers to connect, and what sort of standards do you need in order for one agency to understand another agency's data?
Yeah, so a TLEX is an XML-based message type. You can also use our platform to exchange it, by the way. The thing is, with every message type, you have a standard, but then you need maybe something that we call a message profile standard on top of that. So usually there are optional fields, for instance, in the standard, because it was created to use in a versatile way. So if you want to use it in a large-scale deployment, it would be good to agree on, well, the user's optional fields, limitation of values, and we call that a message profile. And once you have something like that, you can upload it into our platform, and then automatically we check the conformity of all those messages. But some alignment is necessary. But I would like to add to that it's not necessarily the first step that you want to take, because it's not the most difficult thing. It's more difficult to actually start deploying. That seems to be a bigger step for organizations. So I encourage authorities to get started, because changing a message profile along the way is not a big challenge anymore with an environment like this.
Okay, terrific. I'd just like to say, as you're watching this, Menno and Steve, I didn't prepare any of these answers. I've just thrown them at them because things that have come into me, and they've managed to answer every single one of them, which is great. So, can I just ask you, as we're running out of time now, gentlemen, if we could just finish with one takeaway you would like people who've joined us on this webinar, or maybe watching a recording of it later, what is the one takeaway you'd really like them to take from the last hour of conversation?
That we have a solution that unlocks the power of the systems that people have been trying to unlock for years. That by sharing data and creating a cooperative environment for all the stakeholders, there is an awful lot of good that can come, and that it's proven and ready to go today.
Okay, and Menno?
Well, maybe let me add maybe a bit of business here. I think the message is we already have good contacts in the US. There's a lot of interest from agencies and authorities that we see, and we would love to make this happen with other players in the ecosystem. So I think that's we're saving lives in the Netherlands and in other European countries. We would love to do that also in the US, and I think it's a compelling story for authorities. So everybody that's interested, we're welcoming you to reach out and work with us.
Terrific stuff. That's Monotch CEO Menno Malta, and he's also been joined by Steve Voit, Business Development or Business Developer Americas for Monotch. Now, don't forget that if you've got more questions you need to ask, we're going to put the contact screen back up at the end of this webinar, and we'll leave that there for a minute or two for you to note down, and you can scan the QR code and all that. We'll be back in the new year for another webinar from Monotch, but for now, have a lovely rest of the day, or if you're here in Europe, have a lovely evening, and thank you ever so much for joining us on this webinar today. All the best and goodbye.